all throughout our lives, all of us probably are covered in plastic right now, sunglasses and cell phones and pieces of our jewelry nowadays, everything else. We live in a plastic world. Everything's plastic. But for 3D printing, which you can't walk around Maker Faire now without seeing a million 3D printers. For 3D printing, we're really seeing two types of plastic that you're going to see throughout this entire show. You're going to see ABS. ABS is great. ABS is what Legos are made out of, really strong. You step on one, it hurts real bad. But doesn't break, it just breaks you. And PLA is really popular. People are going with it because they don't want to put heated beds in their 3D printers, and it biodegrades if you compost it, as long as it's true, straight PLA and not some kind of crazy additive in it or anything like that. But these are just kind of plain run-of-the-mill plastics. I mean, they're great. They're strong. They print well. But there's only so far we can go with 3D printing when we're just using two types of plastics. And there's a reason why the plastics industry is making hundreds of different types of plastics, because these different materials all have different physical and chemical characteristics to them that can bring a lot to the final product that you're trying to make. So we're getting 3D printing figured out. FDM, fused deposition modeling, FFF, fused filament fabrication, like. We've got that. We've got that pretty figured out. Once again, you walk through this place and you're going to see a million 3D printers, and they all, for the most part, they're doing great. They're working really well. So how do we take 3D printing to that next level? Well, we do it by changing the materials that we're using. We use new materials that are coming out and coming to the market, and use the characteristics of those materials to really be able to push what we're capable of doing with 3D printing. It was interesting for those of you that were in the talk before, she was talking about some of the devices or the things that she was making for her book, talking about making the hamster habitat and how they really wanted, clear see-through panels for the hamster habitat, and that's hard to do, but we're getting there. We're getting there if you use the right plastics. So what do we have now? I said ABS and PLA are what's on the market and the two main things you're going to see, but we have all kinds of things. We have ABS, PLA, nylons, PET, which you're sitting there with a cup of coffee there. More than likely, you're drinking out of a PET piece of plastic. HIPs, high-impact polystyrene, TPEs, thermoplastic elastomers, PCL, commonly called shape lock. So you go over the maker shed and you'll find shape lock little beads. Yeah, you can print in that. Some companies even sell flexible materials, shall we say MakerBot Flexible, which is just PCL with a 600% markup on it. PVA, polyvinyl alcohol, dissolvable in water. Questionable print, but dissolvable in water. Polypropylene, polycarbonate. You go and you get your G.I. Joe or Star Wars figure at the store. They're printing that in polycarbonate. We can print that now. We can print polycarb. So really strong. That's what they make bulletproof windows out of, is polycarb. We can print that out of a 3D printer. Why aren't we? So we have all kinds of varieties in these too. So it gets interesting in how people are taking these makers of these filaments are taking these plastics and combining these plastics together and getting more out of it. So I have an entire range of little gentlemen here. We refer to him as the Dapper Deity. He's a Cthulhu in a tux. This is the model, our little mascot for the 3D printing group that I run out of Providence, Rhode Island. And the first three here we have are all ABS. So we have straight ABS. We have a thermochromatic ABS. So this just has a small additive to it that takes it, and as heat's applied to it, it starts to change color. You can kind of see he's turning yellower now. And then we have an ABS with a carbon additive to it. So, why do you want these additives? Why do I care that, this little guy changes his color? Well, we've been using it to make collars that go onto tubes. So as hot water starts to go through those tubes or a hot fluid goes through, we can tell if it's hot or not just by looking at it. Practical applications for, these simple little devices that have these add-ons. The carbon additive ABS, it's conductive. It's not conductive really well, but they're working on that. So there have been proof of examples of actually printing flashlights. So you print an ABS outside with a conductive material through the inside, pop in a battery, pop in a light bulb, and you have a working flashlight that you printed on a printer. That's changing manufacturing right there. And there's more mixes coming. We have great companies out there that are starting to push more and more of these mixtures of these different types of materials. PLAs, like I said, PLA. These next four that we have, they're great biodegradable plastics, but we can start doing things here. Laywood, there's a gentleman in Europe who's taking PLAs and other filaments and really mixing some stuff in. So this is 60% PLA, 40% wood fiber. You can actually sand this and stain it to look like wood. So I've talked to people who are doing, architectural products where, a finial is missing from a staircase that, they're able to go and print that finial and actually, restain it and make it look like the original just by scanning in the second one. And it still looks like wood. It takes paint. It takes stain. That's great. Lay brick. This one's kind of interesting. It has a really nice feel. I've got some sculptor friends, the gentleman who's created all of these. They really like it because it feels like stone. It was designed to feel like stone. It has a warmth. It has a tactileness that doesn't feel like plastic anymore. Really great for just kind of demo pieces. It's kind of brittle. I'm not really happy about its structural integrity, but for those cases when you're really concerned about the look and not necessarily the functionality. One of the exciting things that's coming out now is flexibles. And I'm going to talk a lot about flexibles actually here. But this is one of the first ones that hit the market. It's a flexible PLA, so I can actually kind of squeeze it, and it's got some flexiness to it. So this is exciting. So now we're starting to get materials that aren't just rigid. So soles on your tennis shoes can now be printed. There's actually a very interesting company back in the corner here that I suggest you guys check out. They're 3D printing shoes. They're scanning people's feet and 3D printing shoes, orthopedic shoes over in that corner. Nylons. Why nylon? Nylon is great. Great material because it's very, very inert. It does not like interacting with other materials. So this gives us a lot of advantages. I'm working with people right now doing some automotive applications. Nylon does not interact with gasoline, so we don't have to worry about it decomposing on gasoline. Nylon is very, very strong and abrasive resistant, so we can make much harder, much more rigid mechanical parts out of nylon. There's all different kinds of nylons that are coming out. Tallman, he's really pushing the nylons that are out there. He's really pushing things to market, coming up with new formulations of nylons that work within 3D printers. They take dye really well, so you see all different kinds of ABSs and PLAs and all these fancy colors. Well, the nice thing is with nylons, you can just go to the grocery store and get a pack of RIT dye, and it will absorb the dye and take that color. So you can take white nylon and make it any color you want just by dipping it in dye. We have this joke of my mother actually making custom, because like hand-dyed yarn sets, but instead hand-dyed custom filament sets from the woods of Pennsylvania as a cottage industry. So Tallman's really pushing things. There's other non-Tallman nylons out there, but I really suggest checking out some of his products. He's working on FDA-approved nylons. So this is a beta sample that I actually worked on. It hasn't been approved by the FDA yet, but that's a long time coming. The raw material is FDA approved. It's just a matter of, is his process FDA approved to make this? So here I'm printing food molds. So for Valentine's Day, my group, we did 3D printed Valentine's chocolates. So printing the molds and casting chocolate directly into it. And because nylon is pretty inert, the chocolate just pops right out, which is great. It's fun. PET, like I said, a lot of packaging comes in PET. Tallman, again, has this T-glass, and there's some other companies selling straight PETs. This is where we're starting to get into the clear. Your plastic water cup or your plastic water bottle is PET and it's clear. We can actually get some functionalities in these prints. If you print with really tall layer lines, we can actually start to get really clear, optically clear prints out of PET. So we can start printing bottles where we see fluid levels inside, or hamster enclosures where we can see our hamsters still inside of it. So it's a lot of fun. And it's really strong. It's really nice. So there's a lot of potentials there. Hips has really caught on. I released some research, and we'll talk a little bit about it, in February of 2013 along hips, and now hips is being sold all over the place. A lot of different vendors are selling hips. MakerBot's selling it as MakerBot soluble, but there's a lot out there for hips. TPEs, so thermoplastic elastomers. This is really where kind of things are getting exciting, at least for me right now, is starting to get things that are actually flexible. So this is NinjaFlex. Some of you may have heard about NinjaFlex, played around with it. Adafruit is doing some really great projects with NinjaFlex. I showed you the flexible PLA. This has a far more stretchy. I can completely compress this, but it maintains its shape. It's very, very strong while still being flexible. Which gives us some really great abilities of, once again, non-rigid structures where we really need that flexibility. So we're seeing a lot of TPs come out, but one of the things that we're catching in here is now we're starting to come into this, the game where, whenever you get money in the game, you start getting people worried about their secrets. So what is NinjaFlex? I don't know. I can tell you that some things are PLAs, and I can tell you some things are polycarb. I don't know what NinjaFlex is because it's proprietary, it's custom. So that's sad, but it's a really great material. It's really great to work with, and I think we're going to see more of that kind of coming down the line of proprietary materials that people aren't really telling us what they are. Yeah, lots of unknowns starting to hit the market, proprietaries. A German company, Aegis, who happens to have their U.S. headquarters in the same state as where I live, in Rhode Island, they're releasing what they call their Tribo filament. We have no idea what it is. I got a sample of it Thursday, some of the first to come into the country. Have no idea what it is, but Aegis sells bearing systems. They sell plastics that are designed to replace steel ball bearings. And now they're starting to release a filament that's the exact same material, so you can start printing your own bushings and your own bearings and things like that that are extremely wear-resistant to mechanical abrasion. So we're looking at the potential of really being able to take, we see too many in the 3D printing world. We see too many tchotchkes, desk toys, cute little things that you sit on your desk. I mean, that's what these are, but this is applicable technology to actually building things that we use in our real lives. I mean, most of the stuff that I print, I don't, other than demos, I don't print a lot of cute things. I print replacement parts for my house. I print other 3D printers. I print mechanical structures. And so now we're really, really starting to see plastics that are coming that are targeted towards that. And this Tribo filament is one of the first that we're seeing that is coming from a company that builds plastics for mechanics, and it's entirely designed towards 3D printing mechanical objects. So mixed materials. This is where I get really, really excited. So we have all these different plastics. We have all these, these thermoplastic elastomers that we can use. But what happens when we start mixing them together? What happens when we don't just have a print that is a single material? We have prints that have multiple materials inside of them. There's a lot more that we can do when we start putting 2 or more extruders into our machine and we're printing multiple materials at a time. Right now, if any of you are in the market to go out there and buy a 3D printer, don't buy a single head machine. Buy something that has multiple heads in it, because you're going to get a lot more out of it. As we continue pushing this and saying, how do these materials mix together and what can we do with it, we're going to do a lot more. It's a lot more than just dual colors. It's dual materials. So the first one that I really demoed, and I alluded to this, was in early 2013. I started playing around with what happens when you print HIPS, high-impact polystyrene, and ABS together. One of the interesting things about high-impact polystyrene is it's dissolvable in a solution called limonene. And limonene is a solvent made from the extracts of orange peels and lemon peels. So it's not bad for you. Too bad for you. Um, but hips will dissolve away in it. So I can print ABS and hips together, and in the end, after I dissolve away the hips, I get structures that are not capable of being printed in a normal print. I can get extreme overhangs that come out clear. So, you know, I can print, yeah, this little cube here, dissolve it away. I've got a blank cube. Here's a toy I was demoing for a small toy company that they wanted to see if it would possibly be capable of creating this toy on a 3D printer. So there it is. Everything white in there is hips, and I can pull that hips away and find myself with just the part of the toy that I actually want. This allows me to also to make pretty tight tolerance mechanical items. So this is a small 3D printed gearbox. So this is all printed in one single print. Everything internal was hips and was dissolved away, leaving me with just the parts that I want. And so I don't have to assemble this afterwards. And you know, this is a pocket toy for a demo, but you can start to understand the idea of I can create mechanical assemblies. I can create finalized things that all get done in one print. So the thing that I've been working on most recently, actually for the past 6-7 months, is, all right, so now I've got hard and soft. Let's start doing these in a single print. Thermoplastic elastomers along with hard ABS. ABS is my print material of choice for a rigid. So let's start printing these things together. So we can print, say, wheels with the tire printed around the outside. So you build a robot and it has grippy tires on the outside, but still has a solid hub that you can attach to your final print. You can start printing living joints inside of something instead of putting in an axle, you know, rod to actually, or a screw to put a joint into something. You print the joint as an actual flexible. So it turns out that ABS and NinjaFlex will actually bond together very, very well thermally. They stick to each other. They stay bonded to each other. So here I have a piece that, you know, prints solid, prints as one piece, but I have full rigidity in it, but I still have the mechanicalness of having a solid piece on the outside. So yeah, I'm kind of wrapping up. I want to save a little time for questions and things, but this is me. If you want to see more about the work that I'm doing, this is where you can contact me. Also, don't run off. One of the companies that I've been working a lot with some of their mixes, Protoplant, has been nice enough to kind of donate some plastics to us to hand out some samples for people to try. So they're creating a lot of mixes that are very useful. They've got an ABS and polycarb mix that gives us a lot of rigidity while still keeping kind of the temperatures and the print temperatures that most people's desktop printers will be able to print at. They have a carbon fiber PLA that they've released, and they have a high temperature PLA, so you can get your PLA prints to be a little bit more resilient. And they have some samples that we're going to be handing out at the end of the talk. But do we have any questions before everyone heads out? Right. Yeah. So the question is the gentleman has tried to print in NinjaFlex and he had problems, and he wants to know, is there a place on the web where he can go and discuss with others and find out more details about how these filaments can be printed. Go to my website. We're actually in the process of putting together a wiki right now. We've been a little slow on it. We've been meaning to do it, but we're starting to create some documentation on how all of these things work. And we want to create an actual scientific testing process, because we've got a lot of people saying, oh, our material's really strong. Well, what's strong mean? Let's get some numbers behind that. So we're in the process of doing that right now. What was that? Yeah, like standardized testing. So we're starting to look into that. We have a mechanical engineer who's part of our group who's been pulling up some of the standards for toughness and shear things, and so we're going to do that. I can't hear you. Yeah, we're going to publish the results. We're going to make a wiki. So not only will we be doing it, but we hope all of you will be doing it too. Are there any safety issues? Most everything that we're seeing right now, these are all materials that have been prototyped for desktop 3D printing. So everything, you know, there's constantly this question of how safe are things to print. There's studies that say that ABS is horrible for you to print with. There's other studies that say it's about as bad as cooking a hamburger on your grill. So, you know, we need more numbers there. But for the most part, everything right now is everything I'm talking about is being sold by companies who are designing it for desktop 3D printing. I'm going to come over here because you've had your hand up for a while. Come back. Conductive material? Yeah. Potentially, yes. So, what was that? Well, the thing is I can't say that yes because I've only been able to see that type of conductive material on a white paper. So I haven't been able to play with it, and I have a hard time saying like, oh, this thing's amazing if I can't vouch for it because I don't want to say that. Right. So the question was with the filament that has the wood fibers in it, is there a way to orientate the fibers? There isn't. They're just kind of mixed in there. And also kind of to your point, none of these are my products. I don't sell anything. I am reaching out to companies, and companies are reaching out to me to beta test their products. So I'm trying to be an impartial judge. I'm not making anything off of this. I am just trying to show these are the things that are out there, and let's create a testing system so that once again, people can't just claim our thing is strong. Instead, we're actually saying, or, you know, this prints great. Because I'm not going to stand up here and say, like, something prints great when it doesn't. This is how everything prints. I'm printing the same model over and over again so that I can show how that thing prints. Metal? All right. One in every crowd. The question was, can we print in metal? No, not necessarily. I mean, there's printers that people are working on. They're working on metal, everything else. In industrial size printers, sure, you can print in metal. But it's hard. Metal's really, really hard to print in. And my challenge to you is, why? We've got all these great materials out there. There's lots of things that we can do. And we can even, you know, we can do things where we can take PLA, print PLA, put it inside of a plaster cast, burn away the PLA, and then cast metal into it. So now we have a metal part. Our lives, like I said, our cars are becoming entirely plastic. Our lives are surrounded by plastic. Metal's great, but we don't need it. We're starting to see, I just read about, there's a company in England that's doing a bronze-infused filament, just like the wood or the sandstone. They're actually putting bronze inside their filament, so you're actually going to be able to polish it, and it'll start to polish and look like bronze. I contacted them and asked for a sample. They basically said no. They said I have to buy it, which is fine. I buy a lot of these, but if I buy everything that I'm testing, I'll be broke, and my wife will kill me. Go for it. I cannot hear you. Do I use an exhaust hood over my printers? I do not. I don't mind the smells too bad of ABS and some of the others. Other people don't like it. I don't really do it. I'm starting to experiment with some things that aren't on the market and they aren't designed for 3D printing necessarily. And so I'm going to do a fume hood over those to make sure that they're not, and put in some sensors to try to make sure they're not pushing toxic gases out. I've got like 2 minutes left, and then if you have additional questions, I'm going to be right by that red robot. And so, yeah. Right. So one of the questions there is some companies are saying, you know, what you can do for changing materials is, you know, they come out with printers with only a single head, pause a print in the middle, and switch out the materials so that you can switch to a different type of material or a different color. That works, but you've got problems there. You know, when you're looking at something like this cube, you know, normally when you want to do that so like the top is printed in one color or one material and the bottom's printed in a different, or, you know, vice versa. So when you're doing multiple materials all on the same layer over and over and over again, you're going to be switching your materials so many times it's going to be ridiculous. So 2 or more heads. Go to PrinterBot. Those guys, yeah. I think that's it. That's probably all the time I have. Come over by the Red Robot. The Protopasta guys are waving their hands over there. They've got samples for you. They have a new website up where you can order their materials.